Hello everyone, my name is Wide West and this is PinoyBIX channel. If you are not my subscriber, please do consider subscribing and don't forget to click the bell button.
This is the multiple choice questions part 3 of the series in computer fundamentals as one of the electronics engineering topic. 101. Which of the following is not an advantage of state tables in sequential logic circuit design? A. They are the systematic approach to a design problem. B. The number of variables is limited. C. They minimize the gating required. D. They result in synchronous circuit. Answer, B. The number of variables is limited. 102. A situation in a system where it can never leave or progress to another state. A. Rest. B. Hang up state. C. No change in state. D. Toggle. Answer, B. Hang up state. 103. A diagram consisting of a set of circles, where each circle contains a number of states within it. A. State table. B. Transition diagram. C. Carnot map. D. Bubble diagram. Answer, D. Bubble diagram. 104. A counter that counts sequentially but does not step through all possible states, it returns to 0 after a particular state. A. Ripple counter. B. Decade counter. C. Truncated counter. D. Binary counter. Answer, C. Truncated counter. 105. A circuit that produces an output pulse for a fixed period of time in response to a trigger and then returns to its quiescent state. A. Monostable circuit. B. Astable circuit. C. Bistable circuit. D. Discriminator. Answer, A. Monostable circuit. 106. A small change made in resistance or capacitance to time a circuit precisely. A. Trigger. B. Tweaking. C. Bounce. D. Squeaking. Answer, B. Tweaking. 107. A square wave oscillator or clock generator. A. Astable circuit. B. Monostable circuit. C. Bistable circuit. D. Debo-undaying circuit. Answer, A. Astable circuit. 108. A circuit designed to produce a clean output in response to a switch closure. A. Monostable circuit. B. Filter circuit. C. Attenuator. D. Debouncing circuit. Answer, D. Debouncing circuit. 109. Duty cycle for repetitive waveform is defined as the A. Ratio of the on-time to the total time. B. Sum of the on-time and the off-time. C. Ratio of the off-time to the on-time. D. Ratio of the total time to the on-time. Answer, A. Ratio of the on-time to the total time. 110. The state of a flip-flop when Q equals 0 and Q prime equals 1. A. Reset. B. Set. C. Trigger state. D. Tri-state. Answer, A. Reset. 111. The state of a flip-flop when Q equals 1 and Q prime equals 0. A. Reset. B. Latch. C. Set. D. Glitch. Answer, C. Set. 112. A state causing the flip-flop to change or reverse its state. A. Reset. B. Set. C. Toggle. D. Non-toggle. Answer, C. Toggle. 113. How many flip-flops should be used to realize 32 count capacity? A2, B4, C5, D6. Answer, C5. 114. The time difference which results when a clock may not arrive at all flip-flops at precisely the same time. A. Glitch. B. Spike. C. Hold. D. Clock skew. Answer, D. Clock skew. 115. A blank condition that exists if a circuit output depends on which of two nearly simultaneous inputs arrive at a point in the circuit first. A. Glitch. B. Skew. C. Clear. D. Race. Answer, D. Race. 116. A one-input JK flip-flop is the blank flip-flop. A. D. B. T. C. SR. D. C. Answer, BT. 117. A JK flip-flop can be made to function like a T flip-flop by simply A. Connecting the J and K inputs together as one input. B. Connecting J equals 0 and K equals 0. C. Resetting all inputs of the JK. D. Connecting earth ground the JK inputs. Answer, A. Connecting the J and K inputs together as one input. 118. The one input R's flip-flop is the ______ flip-flop. A. T. B. D. C. R. D. Latch. Answer, BD. 119. Which of the following does not describe a flip-flop? A. It is a 1-bit memory device. B. Its interval circuitry are usually symmetrical. C. It is a BIST-able device. D. It is equivalent to a one-shot circuit. Answer, D. It is equivalent to a one-shot circuit. 120. In clock circuits, SWG means A. Square wave glitches. B. Standard wire gauge. C. Square wave generators. D. Standard wave ground. Answer, C. Square wave generators. 121. An input signal that can activate or disable a gate. A. Strobe. B. Glitch. C. Tri-state. D. Wired N. Answer, A. Strobe. 122. A ring counter where the output is inverted and tied back to the input. A. Shift counter. B. Decade counter. C. BCD counter. D. Johnson counter. Answer, D. Johnson counter. 123. A circuit that goes through 2(n), states in a random fashion. A. Random generator. B. Pseudo-random sequence generator. C. Counting shift. D. Register. Answer, B. Pseudo-random sequence generator. 124. An input that disables multiplexers or demultiplexers when it is hot. A. Strobe. B. Keyboard. C. Decoder. D. Binary input. Answer, A. Strobe. 125. Application of excessive current to a fuse in order to open it. A. Shorting. B. Blowing. C. Breaking. D. Disconnecting. Answer, B. Blowing. 126. An outstanding advantage of LCDs from LEDs. A. LCDs are organized as a 7-segment display for numerical readout. B. LCDs can be multiplexed. C. LCDs essentially act as a capacitor and consume almost no power. D. LCDs generates light. Answer, C. LCDs essentially act as a capacitor and consume almost no power. 127. A computer language that enables programmable array logic, PAL, users to generate a file that can be used to blow a PAL. A. JEDEC. B. Plasm. C. Turbo C++. D. Visual C. Answer, B. Plasm. 128. A type of computer bus which is bidirectional. A. Data bus. B. Address. C. Control bus. D. Calling bus. Answer, A. Data bus. 129. A table used by a PLD language such as Plasm, to calculate the expected outputs for a set of inputs. A. Excitation table. B. State table. C. Simulation table. D. Truth table. Answer, C. Simulation table. 130. A programmable block of logic within a gate array, that contains a flip-flop for storage and also allows the user to specify logic functions on its inputs. A. Programmed block. B. PLD. C. Configurable logic block. D. Block diagram. Answer, C. Configurable logic block. 131. This type of bus carries the memory address from the computer to the memory. A. Data bus. B. Address bus. C. Control bus. D. Parallel bus. Answer, B. Address bus. 132. This bus carries lines that control the operation of the memory from the microprocessor to the memory. A. Data bus. B. Address bus. C. Control bus. D. Bus lines. Answer, C. Control bus. 133. A register which holds the address of the word currently being accessed. A. Hold register. B. Memory address register. C. Memory data register. D. Access register. Answer, B. Memory address register. 134. A register which holds the data being written into or read out of the addressed memory location. A. Hold register. B. Memory data register. C. Memory address register. D. Glitch register. Answer, B. Memory data register. 135. A pre-production model of a system built for testing and debugging. A. Wire list. B. Maybe, colloquial. C. Prototype. D. Sample. Answer, C. Prototype. 136. Correcting the faults in a circuit or a system. A. Buzz out. B. Debugging. C. Trap. D. Fault corrector. Answer, B. Debugging. 137. There are blank flip-flops for a 3-bit binary counter. A2. B3. C4. D5. Answer, B3. 138. A sequential logic circuit where the storage elements commonly used are time delay devices, usually gates. A. Synchronous SLC. B. Asynchronous SLC. C. Counter. D. Register. Answer, B. Asynchronous SLC. 139. A block added to the combinational logic circuit to form a sequential logic circuit is the A. ROM. B. Counter. C. Clock. D. Memory. Answer, D. Memory. 140. The state of the flip-flop before the occurrence of a clock pulse is called as its A. Present state, B. Next state, C. Current input, D. Present output. Answer, A. Present state. 141. The state of the flip-flop after the occurrence of a clock pulse is called as its A. Current state, B. Present state, C. Next state, D. Current input. Answer, C. Next state. 142. It is said to be a universal gate because any digital system can be implemented with it. A. NAND, B. N, C, or D. Exclusive OR. Answer, A. NAND. 143. A flip-flop which follows its input in the next state. A. T. B. D. C. JK. D. Rs. Answer, BD. 144. An n-bit binary parallel adder requires blank in its least design. A. N-half adders, B. N-half subtractor, C. N-full adders, D. N-half subtractor and N-full adder. Answer, C. N-full adders. 145. A magnitude comparator has 2n entries in the truth table where n equals A. Number of inputs, B. Number of comparator bits, C. Number of outputs, D. Number of inputs and outputs. Answer, B. Number of comparator bits. 146. An included input terminals in a magnitude comparator IC which is significant when both inputs compared are equal is called as its A. Setting, B. Cascading inputs, C. Input terminals, D. Address. Answer, B. Cascading inputs. 147. In designing a 16x1 multiplexer, how many selection lines are needed? A2, B4, C16, D32. Answer, B4. 148. If f equals xy plus x prime y prime Boolean expression is to be implemented using decoders and OR gates, the connection involves A 2 to 4 line decoder with 3 OR gates, B 3 to 8 line decoder with 2 OR gates, C 2 to 4 line decoder with 1 OR gate, D 3 to 8 line decoder with 4 OR gates. Answer, C 2 to 4 line decoder with 1 OR gate. 149. How many AND gates and 4-bit binary adders are needed to implement a 2-bit to 3-bit binary multiplier? A. 15 AND gates and 3 4-bit binary adders, B. 2 AND gates and 1 4-bit binary adder, C. 9 AND gates only, D. 6 AND gates and 1 4-bit binary adder. Answer, D. 6 AND gates and 1 4-bit binary adder. 150. From a 3-bit binary counter design using T flip-flops, determine the number of T flip-flops needed in its circuit implementation. A1, B2, C3, D4. Answer, C3.
Sa mga hindi pa nakapag-subscribe, please subscribe to my channel and don't forget to click the bell button. See you on my next video.